We built a manual for the universe. It took decades. The best minds on the planet, satellites, telescopes, equations filling entire walls. And when we were done, it worked. We could predict how galaxies move, how stars die, how matter clusters at the edge of everything. It was beautiful. It was precise. It was, by any measure, a triumph. There was just one problem. The universe didn't read it. Let me back up. We've known since 1929 that the universe is expanding. Edwin Hubble looked at distant galaxies and noticed something strange. They were all moving away from us. Not just some of them, all of them, in every direction. Space itself was stretching, carrying everything along with it. This was, at the time, genuinely shocking. Einstein had assumed the universe was static. When he heard Hubble's results, he called his own earlier assumption, a number he'd added to his equations to keep the universe still. His greatest blunder. So the universe is expanding. What we wanted to know was how fast. That question has a number. It's called the Hubble constant, and for most of the 20th century, pinning it down precisely was one of the biggest goals in cosmology. By the 2000s, we had a beautiful answer from the early universe. The cosmic microwave background, the faint afterglow of radiation left over from 380,000 years after the Big Bang, is like the universe's baby picture. Study the patterns in it carefully enough. Run the physics forward 13.8 billion years, and you can calculate what the expansion rate should be today. The answer came back, 67.4 kilometers per second per megaparsec. If that unit sounds strange, it is. The point is, the manual said 67.4. We wrote it down. This was the number. Then the second team tried to measure it differently. Instead of the ancient universe, they looked at the modern one. They used Cepheid variable stars, stars that pulse with a known rhythm, reliable enough to work as cosmic lighthouses. And beyond those, exploding white dwarfs so consistent that you can use them to measure cosmic distances like a ruler. They ran the numbers carefully, then again, and published. 73. Not 67, 73. The universe was expanding 9% faster than the manual said. The first team assumed there was an error. Both teams spent years looking for it, checking every assumption, recalibrating every instrument, looking for subtle biases and how they were measuring. Nothing. The number kept coming back, 73. In science, discrepancies get measured in sigma, a way of quantifying how unlikely something is to be random chance. 1 sigma, probably noise. 3 sigma, worth paying attention to. 5 sigma is what physicists call discovery level, an event that would occur by chance less than once in 3.5 million attempts. The gap between 67 and 73 is 5 sigma. This is, technically, a scientific discovery. We have discovered that the universe is not doing what it's supposed to be doing. The manual is wrong or incomplete, or the universe simply doesn't care. Naturally, people started trying to fix the manual. Maybe, some said, there was a form of energy that existed only in the first moments after the Big Bang, a brief burst of something that sped everything up and then vanished completely, leaving no trace except this 9% discrepancy. Entirely hypothetical. No direct evidence, but it would explain the numbers. Others suggested the problem was with the local measurement. Maybe those Cepheid stars are slightly less reliable than we thought. Maybe the cosmic rulers were bent. Both teams spent years poking at each other's methods. Neither found a flaw big enough. Then James Webb launched, the most powerful space telescope ever built. Better resolution, sharper images, more precise measurements than anyone had ever managed before. Everyone expected Webb to settle it. It didn't settle it. Webb looked at the same stars with better eyes and came back with the same answer, 73. If anything, the new data made the case stronger. The gap was real. The local measurement wasn't an error. We bought better glasses and still couldn't read the manual. So here's where we are. 2 teams, 2 methods, both correct, 2 different numbers, and a 5 sigma gap between them that nobody has been able to explain. Maybe there's new physics we haven't discovered yet. Maybe dark energy, whatever it actually is, behaves differently over time than our equations assume. Maybe the early universe had a chapter we didn't know about, and that chapter changed everything that came after. Or maybe the manual was always missing a page. The scientists are still at their desks, still measuring, still writing new drafts. The universe, for its part, continues expanding at whatever rate it feels like, completely unbothered by our confusion. We'll figure it out eventually. Probably. Keep drifting and subscribe to Stardrift FM for more.